Welcome to my next video. In this video, I wanna show you how to solve this equation here. And first of all, we can use the following properties. The logarithm to the base of a of b can be written as the log b over the log of a. Or you can use the natural log or any other logarithm to change the basis here. It's one of the logarithm rules. And yeah, we can replace this logarithm here using this rule here, so that we get logarithm of x over logarithm of 2 plus the logarithm of 16 over the logarithm of x is equal to 5. So now we can multiply both sides with the logarithm of x to get rid of this logarithm here in the denominator. So that we get the logarithm raised to the power of 2 over the logarithm of 2 plus the logarithm of 16 and is equal to 5 times the logarithm of x. Now we can bring this here to the other side, to the left hand side, so that we get the logarithm of x over the logarithm of 2 minus 5 times the logarithm of x plus the logarithm of 16 is equal to 0. Now we can multiply both sides with the logarithm of 2 so that we get the logarithm raised to the power of 2 of x minus 5 times the logarithm of x times the logarithm of 2 plus the logarithm of 16 times the logarithm of 2. So now we can see this 16 here, and to multiply these two logarithms here, we can change the 16 here with respect to this number 2 here. So we can write it as logarithm of 2 to the power of 4. So when we do this, we can use the next logarithm, our second logarithm property here. So when we have something like this here, we can bring this C letter here in front of our logarithm so that we get logarithm C times logarithm to the base of A of B. Okay. So that we get 4 times the logarithm of 2 times the logarithm of 2. And now we can write this two or combine these two logarithms here to get the logarithm to the raise to the power of 2. And so in the next step, we get the logarithm raised to the power of 2 of x minus 5 times logarithm of x times the logarithm of 2 plus 4 times the logarithm raised to the power of 2 is equal to 0. Now we can substitute this logarithm here with the letter u. U is the logarithm of x here, so that we get a quadratic equation minus 5 times u times the log of 2 plus 4 times log raised to the power of 2 is equal to 0. So now we can use the following formula. This here is our P letter, and this here is our letter Q. So we can use the PQ formula just like this. First I will write it as P and Q, and then I will replace it with these logarithms here. Minus P over 2 plus or minus P over 2 raised to the power of 2 minus Q and the square root of this. Okay. So we get, this minus sign here is also included, so that we get minus 5 times the log of 2 over 2 plus or minus 5 times minus 5 times the logarithm of 2 over 2 raised to the power of 2 minus 4 times log the raised to the power of 2, 2 square root of this. And with this, we have in the next step, minus and minus will be plus or positive 5 times log of 2 over 2 plus or minus. This is, this minus sign here will be positive, will be a plus sign, so that we have here 25 times log raised to the power of 2 over 4 minus 4 times the logarithm raised to the power of 2, and so on, just like this here. So now when we write, when we bring these two together here, so that we have here also 4, then we have to extend or expand here, or we can multiply with 4 this fraction here, so that we get 16. And now we can subtract 25 times the logarithm raised to the power of 2 with 16 here. Yeah? And we will get plus or minus 9 times the log raised to the power of 2 over 4 and the square root of this. So now we can take the square root of 9. It will be 3 when we take the square root of this power here. Then this this number 2 here will be cancelled with the exponent of the square root. It's raised to the power 1/2 of 1/2, and when we take the square root of 4 here, it will be 2. Times the logarithm 2 over 2 plus or minus over 2. And our first solution will be when we look at this plus case here. So we would add 5 times the logarithm of 2 here, this nominator here. So we get 8 times the logarithm of 2 over 2, and we can cancel 8 with 2, and we get 4 times the logarithm of 2. And for our other solution, we would subtract here 5 with 3, and we will get 2 times the logarithm of 2 over 2, and this cancels each other out here, so that we only have the logarithm of 2 here. Now when we use the resub, so we would get here a log of x1 is equal to 4 times the log of 2. So we can bring this 4 here in the next step inside our logarithm here. So we will get the logarithm of 2 raised to the power of 4, which will be 16. So since we are using here the logarithm, um, it's to the base of 10 here. No? When we use the logarithm with no base is mentioned, then it's always the base 10. It's always the logarithm to the base of 10. So in the next step, here I would raise both sides or use the inverse function of the logarithm to the base of 10. It will be 10 to the power of x here. So I have to use the logarithm here inside. I have to place or put this logarithm of 16 inside this x here. And on the left hand side, I would do the same, so that we will get the 10 raised to the power of logarithm x1 is equal to 10 raised to the power of log of 16 here. And with this, our base and exponent here, exponent function, would will be cancelled, and what still remains is this argument here, x1 and 16. So our first solution will be 16. And our second solution, when we use our resub here, then it's only this logarithm of 2. Then I use 10 raised to the power of x here, and we will get x2 is equal to 2. So, and these two solutions are our final answer. And thank you for watching this video, and leave a like if you did. So you can also leave a comment in the comment section, and see you in the next video.